Layer 1 and Layer 2 are terms that help us understand the architecture of different blockchains, projects, and development tools. But what exactly is Layer 1? Welcome to Caffeinated_Crypto, #1 YouTube channel for crypto education. What is Layer 1? A Layer 1 network is another name for a base blockchain. BNB Smart Chain, Ethereum, Bitcoin, and Solana are all Layer 1 protocols. We refer to them as Layer 1 because these are the main networks within their ecosystem. In contrast to Layer 1, we have off-chains and other Layer 2 solutions that are built on top of the main chains. In other words, a protocol is Layer 1 when it processes and finalizes transactions on its own blockchain. They also have their own native token, used to pay for transaction fees. Let's now discuss what Layer 1 scaling is. A common problem with Layer 1 networks is their inability to scale. Bitcoin and other big blockchains have been struggling to process transactions in times of increased demand. Bitcoin uses the proof-of-work consensus mechanism, which requires a lot of computational resources. While PoW ensures decentralization and security, PoW networks also tend to slow down when the volume of transactions is too high. This increases transaction confirmation time and makes fees more expensive. Blockchain developers have been working on scalability solutions for many years, but there is still a lot of discussion going on regarding the best alternatives. For Layer 1 scaling, some options include: 1. Increasing block size, allowing more transactions to be processed in each block. 2. Changing the consensus mechanism used, such as with the upcoming Ethereum 2.0 update. 3. Implementing sharding, a form of database partitioning. Layer 1 improvements require significant work to implement. In many cases, not all the network users will agree to the change. This can lead to community splits or even a hard fork, as happened with Bitcoin and Bitcoin Cash in 2017. What is Layer 1 sharding? Sharding is a popular Layer 1 scaling solution used to increase transaction throughput. The technique is a form of database partitioning that can be applied to blockchain distributed ledgers. A network and its nodes are divided into different shards to spread the workload and improve transaction speed. Each shard manages a subset of the whole network's activity, meaning it has its own transactions, nodes, and separate blocks. With sharding, there is no need for each node to maintain a full copy of the entire blockchain. Instead, each node reports back the work completed to the main chain to share the state of their local data, including addresses, balance, and other key metrics. Layer 1 versus Layer 2. When it comes to improvements, not everything is solvable on Layer 1. Due to technological constraints, certain changes are difficult or almost impossible to do on the main blockchain network. Ethereum, for example, is upgrading to proof of stake, but this process has taken years to develop. Some use cases simply cannot work with Layer 1 due to scalability issues. A blockchain game could not realistically use the Bitcoin network due to the lengthy transaction times. However, the game may still want to use Layer 1's security and decentralization. The best option is to build on top of the network with a Layer 2 solution. Lightning Network. Layer 2 solutions build on Layer 1 and rely on it to finalize its transactions. One famous example is the Lightning Network. The Bitcoin network under heavy traffic can take hours to process transactions. The Lightning Network lets users make speedy payments with their Bitcoin off the main chain, and the final balance is reported back to the main chain later. This essentially bundles everyone's transactions into one final record, saving time and resources. Layer 1 blockchain examples. Now that we know what Layer 1 is, let's look at some examples. There's a huge variety of Layer 1 blockchains, and many support unique use cases. It's not all Bitcoin and Ethereum, and each network has different solutions to the blockchain technology trilemma of decentralization, security, and scalability. Number 1. Elrond. Elrond is a Layer 1 network founded in 2018 that uses sharding to improve its performance and scalability. The Elrond blockchain can process over 100,000 transactions per second. Its two unique main features are its secure proof-of-stake consensus protocol and adaptive state sharding. Elrond's native token EGLD is used for transaction fees, deploying dApps, and rewarding users that participate in the network's validation mechanism. Number 2. Harmony. Harmony is an effective proof-of-stake (EPOS) Layer 1 network with sharding support. The blockchain's mainnet has 4 shards, each creating and verifying new blocks in parallel. A shard can do this at its own speed, meaning they can all have different block heights. Its native token, 1, is used to pay network transaction fees. It can also be staked to participate in Harmony's consensus mechanism and governance. Number 3. CeeLo. CeeLo is a Layer 1 network forked from Go Ethereum in 2017. It has, however, made some significant changes, including implementing POS in a unique address system. The CeeLo Web3 ecosystem includes DeFi, NFTs, and payment solutions, with more than 100 million transactions confirmed. Similarly, Thorchain, Kava, IoTex are more such solutions. Today's blockchain ecosystem has several Layer 1 networks and Layer 2 protocols. It's easy to get confused, but as soon as you grasp the basic concepts, it becomes easier to understand the overall structure and architecture. This knowledge can be useful when studying new blockchain projects, especially when they focus on network interoperability and cross-chain solution. Your host DJ signing off. Goodbye, be back soon.